Hello students, I am Saili Rathod from International Center of Excellence in Engineering and Management, Aurangabad. Today I am here to present a video lecture, that is video number 12 of Digital Electronics subject, whose subject code is 204. The today's topic that we are going to cover in this video lecture is logic families, that is different types of logic families we are going to see: RTL, DTL, ECL, MOS, CMOS, etc. So all this part, that is the logic families, it is of the second unit, that is Introduction to Analog and Digital Signals. Up till now in this second unit we have seen the basics of what is analog signal, what is digital signal, how they are represented. Then we have seen different types of logic gates. We have seen the classification of gates. Basic gates we have seen, universal gates we have seen. So up till now we have covered all these basic concepts. Now we will move towards the logic families and we will see each logic family in detail. So let's move ahead. Here we will see what is actually the logic family. As we know that we have different types of gates, basic gates, which can be used to design a particular circuit. But from what these gates are formed? These gates are manufactured using semiconductor devices like BJT, diodes or FETs. So using these components, these gates are designed, and according to the components that we have used for this particular gates, we can give a particular logic family name to that particular circuit. So this is the basic concept of logic family. The point says logic gates like NAND, NOR are used in daily applications for performing logic operations. The gates are manufactured using semiconductor devices like BJT, diodes, FETs, etc. Different gates are constructed using integrated circuits. Digital logic circuits are manufactured depending on the specific circuit technology or logic family. Okay, so in this point there is a point which says different gates are constructed using integrated circuits. What does it mean? There are integrated circuits, which means integration of different components or combination of different components forms a particular circuit. These circuits are given a particular logic family name, so we call it a logic family. Now we will move ahead and we will see what are the different types of logic families. The different logic families are RTL, which is also called resistor transistor logic, DTL, that is diode transistor logic, third one is TTL, that is transistor transistor logic, then the ECL, which is emitter coupled logic, then the CMOS, which is complementary metal oxide semiconductor logic. The RTL, DTL, these are the previously used logic families, but after the invention of the ICs, most of the times these RTL, DTL are not used nowadays. From all these logic families, the ECL, CMOS as well as the TTL, these are mostly used nowadays. As comparatively if we see, the lowest power consumption is in the CMOS family. So if the power is less or you want a less power consumption, you can use CMOS, and if you want the fastest operation, then you can use the emitter coupled logic. So ECL is the fastest working logic family and CMOS is the least power consumption family. Now we will see, before moving towards the detail of each logic family, we will see the features of the logic families. The different features are: first one is fan in, then fan out, power dissipation, noise immunity, propagation delay. Okay, so we will see one by one. Fan in. Fan in is defined as the number of inputs a gate has. It means whatever the number of inputs we want to give to that particular logic family, it represents the fan in number of that logic family. For example, here in the first figure you can see the input is only one A, that is the circuit, it will be having the fan in 1. And in the second figure, the OR gate, for that the inputs are 2 A and B, so we can see the fan in number is 2. Now what is fan out? Fan out is defined as the maximum number of similar gates which can be driven by the gate. For an example, we will see this concept by an example. A fan out of 5 indicates that the gate can drive at the most 5 inputs of the same IC family. Means if you say any number of fan out number of a particular circuit, it means that particular gate can drive the same number of inputs. If for an example we are designing a logic family of NOR gate, 3 input NOR gate, then we can see it can drive 3 inputs of the same IC. So this is the feature, second feature of the logic family. It is very important for the smooth working of the circuit to define its fan out. So it is very important to predefine the fan out number of that particular circuit. Higher the fan out, higher the current supplying of a gate. So this is the fan out feature. Now we will see the noise immunity. Now what is the noise immunity? As we know, wherever when a particular circuit is working, there are many times chances to introduce the noise in that particular circuit if the background is having noise. So the circuit must be having a good immunity towards the noise. It means whether the input whether the circuit is working in the noisy environment, but still the output should not get affected by that noise. So noise immunity is defined as the ability of a logic circuit to tolerate the noise without causing any unwanted change in the output. This is called the noise immunity. The noise signal can be AC or DC. Okay, so depending upon the environment where or the complete requirement, the noise may be of AC or DC. In power electronic equipment, the environment noise is very high and the reliability of a digital circuit under such noise environment is of great importance. So this feature is very important because the circuit should not get affected by the noise, or the output of that circuit should not get affected by the noise even if it is working in the noisy environment. So this is the third feature. Now we will see the propagation delay. Now what is the propagation delay? As we know, in digital circuits there are two states, 0 and 1, and the input can get switched between 0 and 1, or accordingly the output may also get switched between 0 and 1. But at the time of switching, the signal does not abruptly changes from 0 to 1 or 1 to 0. It requires some particular time to get switched between these two states. So this particular time or delay, we can say the propagation delay. The output of a logic gate does not change its state instantaneously in response to the change in the state of its input. That is, when input is changed from 0 to logic 1 and vice versa, then the output of logic circuit does not change immediately. There is a time delay between these two events, which is called a propagation delay. So very easy concept. Propagation delay means what? This is the delay which is caused while switching the state from one level to another level. So the propagation delay, it is also have two types, that is TPHL and TPLH. TPLH is what? The propagation delay which is measured when the output is making a transition from high to low. As the name indicates, TPHL means high to low, and the TPLH is the propagation delay which is measured when the output makes transition from low to high. Okay, so I think this concept is clear to everyone. Now the next feature is power dissipation. As a result of applied voltage and current flowing through it, that is logic ICs, some power will be dissipated in the form of heat, which is known as power dissipation. So what does this power dissipation means? When the voltage is applied and the current is flowed through the circuit, at that time there is some conversion of the energy from one form to another, and there are many times chances that the power may get dissipated or absorbed in that particular circuit in the form of heat. So this type of power dissipation in the form of heat or in any form is called as the dissipation of that power. Power dissipation is denoted by PD is equals to VCC into I, that is voltage into current. Normal working power dissipation in the circuit should be minimized. So it is very obvious that is power dissipation should be minimized or it should be low. If the power dissipation is high, then it may be the disadvantage of that circuit because the power is getting absorbed or drained at somewhere. So for a good working circuit, power dissipation should be less or minimized. Now we will see the logic families one by one. The first one, that is resistor transistor logic RTL family. The resistor transistor logic, also termed as RTL, was most popular kind of logic before the invention of IC fabrication technology. Okay, so friends, nowadays in many circuit we use the ICs. So before the invention of this IC or before the invention of IC fabrication technology, the mostly used logic was the RTL. As its name suggests, RTL circuit mainly consists of resistors and transistors that comprises RTL devices. Means the circuit, it is the combination of some resistors and the transistors. In the next slide we will see the circuit diagram of the RTL logic family. The basic RTL device is a NOR gate shown in the figure aside. So for designing a NOR gate, we are using the RTL family, which is combination of resistors and transistors. Input to the NOR gate shown in the above figure are input 1 and input 2. The inputs applied at these terminals represent either logic level high or logic level 0. The logic level low is the voltage that drives corresponding transistor in cutoff region, while logic level high drives it into saturation region. So these 2 points are very important. Now see in this circuit diagram, here you can see 2 inputs in the circuit at the lower side. Here we can see the input 1 and input 2. There are 2 transistors, that is T1 and T2. As the first point says, the input to the NOR gate shown above are input 1 and input 2. So the inputs may be a logic 0 or logic 1 according to the truth table. And the last point says the logic level 0 is the voltage that drives corresponding transistor in cutoff region, while the logic level high drives it into saturation region. It means from figure you can see if the input 1 is given 0, then the connected transistor, that is T1, it will get cut off into the cutoff region. And if the logic level high, that is 1, is given as input, then the transistor 1, it will go into the saturation region. So the transistor will switch on. So depending upon this logic, the RTL family works. So now we will see how does the complete circuit works. Here the circuit diagram is shown where 2 transistors T1, T2, input 1 and input 2, and the VCC which is connected to the RC and the output. Okay, and there is one ground between input 1 and input 2. Now the condition, if first condition is if both the inputs are low, then both the transistors are in cutoff, that is they are turned off. Thus voltage VCC appears at output, that is high. Now see, from the truth table, if both the inputs are given 0, then what will happen? This transistor will be off, this also transistor will be off. So the current from VCC, it will not go towards T1 T2, it will directly flow towards the output and it will be giving 1. So this is the first condition. Now from truth table you can see, if input are 0 0, then the output is 1. Now the second condition, if either transistor or both of them are applied high inputs, the voltage VCC drops across RC and the output is low. Now for the other three conditions, if any of the transistor, either transistor 1 or transistor 2, is logic 1, means if here it is 0, here it is 1, or here is 1 and here it is 0, or if both the inputs are 1. So in these three conditions, the output here will be 0. Why 0? Because if both the inputs are 1, then what will happen? It will switch on T1 and T2. So if it is switched on, then the current will flow from this and it will go towards the ground. If T2 is also on, then the current will flow like this and the current will be drained to the ground. Thus there will be no flow towards the output. So it will give 0 at the output. So in all the three conditions, so in this way all the outputs will be 0 for the rest of the three conditions. I think the concept is clear to everyone. Simply just remember the circuit and the truth table following for the RTL, that is the NOR gate. RTL family is characterized by poor noise margin, poor fan out capability, low speed and high power dissipation. Due to these undesirable characteristics, this family is now obsolete. Means nowadays this circuit is not generally used due to this following undesired characteristics. Now the next logic family we will see, that is the diode transistor logic family. As from the name we can see, the circuit is consisting of diode and the transistors. The diode transistor logic, also termed as DTL, replaced RTL family because of greater fan out capacity and more noise margin. So due to the undesired characteristics of the RTL, the next level, that is diode transistor logic family, was invented and it is mostly used as compared to the RTL. As its name suggests, DTL circuit mainly consists of diodes and transistors that comprises DTL devices. The basic DTL device is a NAND gate shown aside. Now we will see the logic circuit of the DTL family and we will see the truth table, how we can construct the circuit, and it verifies for the NAND gate truth table. Okay, so in this figure you can see the circuit consists of diodes D1, D2, D3, DA and DB, and you can see the resistors connected in that circuit. So it is a combination of resistors and the diodes. As we know, this DTL can be used to construct the NAND gate. So we have taken here the NAND gate truth table and the logic diagram of the NAND gate. Here we have three inputs ABC and the output is A dot B dot C bar, as it is a NAND gate. Now we will see one by one. Three inputs to the gate are applied through three diodes D1, D2 and T3. Here from the figure you can see 3 inputs 1, 2 and 3. They are going in from the diodes D1, D2 and D3. The diode will conduct only when corresponding input is low. If any of the diode is conducting, that is when at least one input is low, the voltage at cathode of diode DA is such that it keeps transistor T in cutoff and subsequently output of the transistor is high. So from the circuit we can see when all the 3 diodes are off, then the DA and DB, this diodes also does not conduct. So when this diodes does not conduct, the transistor is in the cutoff region. So the current will not, the VCC current will not pass through this transistor. The current will directly go towards the output and it will give 1. And opposite to that, if all the diodes are conducting, the transistor will get on, and if the transistor is on, then the current will pass like this and it will go towards the ground, resulting into the output 0. So like this, one by one condition we can satisfy the truth table. From the truth table you can see if all the inputs ABC are 0, then in that case the output is 1. And for all the rest of the conditions, only one condition, the last, that is if all the inputs are high, then the output will be low, and for all the rest of the conditions the output will be high for the all combinations of the input. Okay, so the concept is very easy. You have to remember only the circuit and just remember the truth table of this circuit. Using that you can explain the circuit, that is for what input you will get what output. If all inputs are high, all diodes are non-conducting, transistor T is in saturation and its output is low. Okay, so this condition means what? This is the last condition of the truth table. That is, if all the inputs are high, all diodes are not conducting, transistor T is in saturation region. This is in saturation region, means it will be on and the output will be low. Here you will get the output low. Due to number of diodes used in this circuit, the speed of the circuit is significantly low. Hence this family of logic gates is modified to transistor logic, that is TTL family. So this is all about the DTL logic family. So up till now we have seen 2 logic families, that is RTL and the TTL. I think these concepts are clear to everyone. In the next lecture we will see the TTL, then we will see the ECL and MOS and the CMOS family. So till that, keep studying. Just revise these 2 types of logic families and also the features of the logic families. Thank you so much.